So in this example, we try to get x by itself. We do have parentheses, so we're going to go ahead and distribute. And again, since this is so similar to yesterday, I'm going to go through the beginning parts of this very quickly, and we're going to focus on the end where it's actually a little different. So if I distribute the 2, I should end up getting 6x plus 2 greater than or equal to 7x plus 4. Now we've got variables on both sides. Yesterday we said it may be helpful to split this down the middle to keep track. You don't have to do that, but a lot of people thought it was helpful. I want to get my x's together. I've got 7x here, I've got 6x here. I'm going to subtract 7x on the right to get rid of it on this side. But whatever you do on one side, you do on the other, so I'm combining them on the left. 6x minus 7x, well, if you had 6 and you gave away 7, or if you had $6 and you owed 7, any way you want to look at it. Doesn't matter. So 6 minus 7 is going to give me a negative 1x. And remember, when we have a 1, we usually don't write it. You can if you would like. And everything else stays the same. So now it's 2 steps. I'm going to subtract 2 on both sides. So that's going to give me negative 1x greater than or equal to 4 minus 2 is 2. And here's where I want to slow down and talk about what's different. In an equation, we would just do one little thing with the negative sign and be done. In an inequality, something else is going to change. Does anyone remember from yesterday, we saw this yesterday, how I can get rid of the negative sign in front of x? There are several different ways we could do this. Savannah? Yeah. You divide by a negative. Remember, negative x is the same as negative 1x. So what we're doing is dividing by negative 1 on both sides. But here's the problem. I've got x by itself, but in an inequality, what we just did changes something. This is one weird little rule. It's the only thing that really makes solving this any different than an equation. Raise your hand if you remember the one weird little rule that we have with inequalities that is different from equations. Leah? Right. We're going to flip the inequality sign. Do you remember why? Like, when do we do that? That's a different thing, but we can get to that in a minute. Savannah? Absolutely. We had this rule. If you multiply or divide by a negative, and look, we did right here. We divided by negative 1. Divided by negative 1. If you multiply or divide by a negative, this inequality symbol in the middle has to flip around. 2 divided by negative 1 is negative 2. That is our solution, but we are asked to graph this on a number line at the end. So let's take a look at that. You always want to have 0 on your number line. It's a point of reference, so we know if we're talking about positives or negatives. And negative 2 would be over here on the left. And we have to remember a few things about this graph for this all to make sense. And we'll write it off to the right here so we can see it all at once. We have 4 different symbols that you sometimes see. Greater than, less than, greater than or equal to, less than or equal to. These 2 up here do something different than these 2 down here. For these 2, greater than or less than, when you graph it, one of them will be an empty circle, one of them will be a solid dot. Does anyone remember which? Ivan? Which one am I going to fill in? One of these I'm going to fill in inside the circle. Right. It's the ones that say equal to, because that means I'm including this spot on the graph. So I had negative 2, so I'm going to make a circle. It says or equal to, it's underlined, so I'm going to fill it in because it includes the number negative 2. But now we have to draw an arrow. It's either supposed to go left or right. And we had a couple ways of remembering this. Noah? Yeah. So one of the ways we looked at was, look at this symbol right here. it looks like an arrowhead pointing to the left. And it tells us to point to the left. The only time that's a problem is what if we had the answer written the other way? Like what if it said -2 is greater than or equal to x? Who remembers what we said we would do if it was written this way? Noah? Right. This is just a mirror image of what we ended up getting. You just flip it back around. So -2, closest to the mirror, -2. The symbol gets flipped around in the mirror image, and then x over here, x over there. So you just make a mirror image of it to flip it back, and then you can say, yeah, it points to the left. Doesn't matter if it's positive or negative at the end. Just if it's written backwards like this, you just flip the whole thing around. Robert? Nope, that's what Noah was asking too. A negative answer doesn't change anything weird about how you graph it. It's just this step. When you divide it by a negative, we flip the symbol. That's the only thing that a negative does. No, not for that. Not for that. That was just for the solving, not for the graphing.